Okay, so in this video, we're going to talk about using the properties of logarithms to expand and condense logarithmic expressions. Now, coming back to our properties of logarithms, these are going to be the big ones to remember. If you don't have these somewhere, you might want to pause this video and take a chance and write those down. For those of you that are in my classes, I have posted this on Google Classroom, so you do have access to these properties, as well as the conversions that are being shown earlier, which would be these ones right here. So using these properties, so I'm going to even set this right up here. We probably won't be able to see it all that great, but we'll try. So we're going to look at this and determine, okay, I have a log minus another log. So I'm looking at this side right here and say, okay, I have log m minus log n. Well, that's going to turn into log of m divided by n. So this right here is my m, and this right here is my n. So I have a single log out front. This base right here that it's talking about, when there's no base written, it's just 10. So then I'm just going to do m divided by n. So I'd have x divided by x plus 1. If I could simplify that, I would, but I can't. These x's cannot cross off because there's this plus 1 here. So this right here is my final answer on this problem. So the next one's going to be considerably longer. So let's try this one first, okay? So with this, remember our order of operations, we do what's in the exponent or in the parentheses first. So we have a parenthesis with a plus. Well, plus means multiplication. So we're going to deal with that multiplication first. So this would be my m of that multiplication, and this would be my n of that multiplication. So I'm just going to rewrite everything else. I'm even going to keep this parenthesis here. So with that multiplication, I'm going to have log base 3 of 2 times q. I put it together with multiplication. All right. So we do parentheses, and then order operation says, okay, then deal with exponents. Well, our exponents are these numbers out front. So these numbers out front, according to my power property, jump up on whatever's inside the logarithm. This one is fairly easy. We know it's going to hop up here on top of this p. So we're going to go ahead and rewrite this. Log base 3 of p squared minus, we're going to leave the minus here, but we are going to hop this 4 up here. And it does actually go on both of them. It goes on everything in there. So we have minus log 2 to the 4, 2 to the 4. Well, I can simplify that a little bit still. I'm going to go and rewrite this. Drop the base 3 there. Okay, 2 to the 4. 2 times 2 is 4. 4 times 4 is 16. So this will be 16 2 to the 4. All right. Then the last property that we're going to use is this subtraction, which means it turns into division. So when you do that, this is my m, this is my n, and I'm going to rewrite it as that. So I'm going to have log base 3 of m divided by n. Everything is condensed. I can't simplify anything. This right here is my answer. So that is how we condense. So if we're condensing, that makes it much easier. A shortcut way to think about it is if it's positive, so deal with the powers first, and I could have dropped this 4 up on all of these and distributed this negative. But if it's positive, it's going to wind up on top. And in the long run, if it ends up being negative, because both of these would end up being negative with this negative out front, it's negative, it's going on the bottom. All right, so that's condensing. Now let's talk about expanding. So we're going to work on expanding these, but I want to rewrite this first with that root rewritten as an exponent. It makes it easier to mess with. I'm going to have x, y to the 1/4. Okay, when I have xy to the 1/4, I'm going to look at this and say, okay, I have a multiplication there. So multiplication, according to my properties, is going to turn into addition. So let's rewrite that and say, okay, that means ln of x plus ln of y to the 1/4. And then the last thing says, hey, you have an exponent here, don't forget to throw it out in front. And the reason why we didn't throw that out in front to begin with is that 1/4 is only on the y. So we had to isolate that part before we could actually deal with that exponent. So we're going to have ln of x plus 1/4 ln of y. That right there is your answer. All right, the second one, a little bit more difficult. If we use the idea that I talked about on the last one, where anything on the top is going to be positive, anything on the bottom is going to be negative, because remember this top minus bottom when you have logarithms, we can actually break this apart pretty quick. Here's something I do want to point out to you though. We've got 1, 2, 3, 4 pieces. That means you're going to have 4 separate logs. So I'm going to go ahead and write out, I have log base 5, log base 5, log base 5, and log base 5. Now, what goes in these logs are those 4 separate elements. So on the top, I have x to the 4th. All the rest of these are on the bottom, so all of the rest of these will be minuses. So here, I'm going to have a 2, a y, and a z to the 2. Then I look at these exponents. All right, if I have exponents, they drop out in front of the one that they're on. So for this one, I'll have 4 log base 5 of x minus log base 5 of 2 minus log base 5 of y minus 2 log base 5 of z. That right there, you've got everything taken care of. Nothing else is being multiplied, divided. There's no powers on anything. That is your expanded form. The long-running application to this really can show up in later classes. You're just kind of learning the basics and refreshing them here. But I definitely have seen a huge application of this with calculus when we do derivatives. It's much easier to derive something like this versus something like this. And so that's when we really use those applications. But if you have questions on any of this, feel free to leave a comment. If you're one of my students, make sure you hit me up during my office hours. Thank you.